Hello everyone, my name is Ikra Ansari. I'm from group number 324. Today we will going to discuss about the generation of the nerve impulse. So the current voltage characteristic of the axon membrane is specific. It is not only non-linear but contain a portion with a negative slope. This is a consequence of the dependence of the sodium and the potassium conductance on the membrane potential. Let us consider the generation of the action potential in a homogeneous section of the axon. Since at the first step the depolarization, the potassium conduction is very slow. So first, this is the depolarization. In which the K conductance is very slow. Okay, we assume the ionic current to be the sum of current of the sodium and the leak current of the Y. The leak current is defined by the Ohm's law as a difference between when the active potential and the resting potential divided by the resistance of the membrane. So it is given as potential minus upon the resistance, which is equals to or the time dependence of the sodium may be approximately by the rectangular or well, if we assume that a current of the constant value sodium exists within the time interval from the moment its peak value is reached to the amount T3, when the sodium current falls off during the remaining time interval, the IN is equals to 0. The experiment carried at a fixed potential show that the dependence of the IN on the mu is non-linear, that is the dependence of the GNA on the mu is non-linear. However, with the instantaneous jump of the potential conductance, sodium has no time to change, and according to the experiment carried out by the Hodgkins and the Huxley is linear dependent, that is mu minus mu current. Okay, so we will going to draw the graph for the better understanding. So this is the slope. In this there is so this is the graph, and the next graph is like this, which is the sigmoid like graph. Sorry, I made it wrong. Okay, so this experiment carried out fixed potential show that the dependence of the IN on a mu of is non-linear. However, with the instantaneous jump of the potential, the conductance has no time to change according to the experiment carried out. Let us replace the experimental current linear with the discrete absolute value, which is given as DINA sodium upon, which is equals to G1 at and G2 the voltage current characteristic of the peak sodium current is described by the formulas, which is G1 and the G2. This is the formula to calculate. Thank you so much.